Our last example in this lesson, example 6, is an application problem, and it says for non-extreme weather months, Clemento Electric charges $7.10 plus 6.747 cents per kilowatt hour for customers using up to 12 kilowatt per hour, and charges $88.06 plus 7.788 cents per kilowatt above 1200 for customers using more than 1200 kilowatts. So part A wants us to write the function that gives the monthly charge, keyword there, in dollars as a function of a kilowatt used. So that's a little bit of a problem. If we're wanting to charge in dollars, and I have been given, yes, two numbers in dollars, but then these other two are in cents. So we have done a problem like this before in module 1. We need to do some dimensional analysis to convert our cents into dollars. So if I take this first number here, we have 6.747. I'm going to put a C for cents. And I need to multiply this and convert it into dollars. So we know that 100, where do I want to write this? We'll do it up here. 100 cents equals $1. Okay, those are equivalent amounts of money. So it does not matter if I want to put 100 cents over $1 or $1 over 100 cents. Either way, I am multiplying it by 1. Now, if the goal is to get my cents to cancel, I need my other cents in the bottom. So that means I want my $1 in the top. So I'm going to do $1 over 100 cents. So we can make this into a fraction by putting it over 1. And now we can see my cents here are going to cancel. So I am left with 6.474 times 1, so it's 6.74 dollars over, I have no units in the bottom, but I do have 100. So if I divide that by 100, all it does is move that decimal 2 places over, and we get 0.0747 dollars here. Okay, so I can do that same thing, and if I put that here, all I'm essentially doing is dividing it by 100. So 5.788 divided by 100. Again, it takes that decimal, moves it 2 units over. And so this is equivalent to 0.05788 dollars. Okay, so now we have everything in dollars, so now we can make our function. You can kind of see how this is a piecewise oh, that's really bad. Let me try that again. We're doing those nice squiggly brackets. That's much better. Okay, you can see how this is a piecewise defined function because if we are using up to 1200 kilowatts, we are dealing with this amount of money. And then once I go above 1200, I've got different charges, different increments, right? So if I am less than 1200, we have a one-time charge of $7.10. So that is 7.1. You could put 0.10 if you want, but I don't really need that decimal there. So 7.1 plus it tells me this many cents, which we converted to dollars. And the key word there is that per. That means we're multiplying that. So that is 0.06747x. And we're using this function here if X is less than or equal to 1200. It says up to 1200. So that's where my equals is right there. Okay, now that one should be pretty straightforward. The second one is a little bit different than how we would think it to be. So that's why I wanted to do this example. You will see this question in my math lab. Okay, we are getting charged 88 cents, or sorry, $88.06. So that will be my starting point. Okay, and then plus this much per kilowatt, keyword above 1200. So I'm just going to go ahead and write this, and then I'm going to explain. So we will do our amount in dollar, but it is not this amount X. It is times X minus 1200. And for this one, we will use it if X is greater than 1200, not greater than or equal to, but greater than 1200. Now, why? Why do I have this portion right here for that second equation? Okay, I'm just going to go ahead and box this real quick. This is my answer. But let me try to explain this. Where does this number right here come from? Well, if I plug in 1200 into this equation here, I have 7.1 plus 0.06747 times 1200. I get this number here. So this comes from my top equation. When I plug in that 1200. So I am already getting charged for all 1200 kilowatts that I'm getting used right here. So now I'm taking that number here, and now anything above that 1200 kilowatts gets charged this new rate right here. But let's say I use 1300. If I do this times X times 1300, now I'm getting double charged for that first 1200 kilowatts. So if I do 1300 minus 1200, now I'm getting charged this amount for only that additional 100 kilowatts that I'm going over this amount here. Okay, hopefully that kind of makes sense. So here, what is the monthly charge if 960 kilowatts are being used? So which function am I talking about? I need to use this top one here because I'm less than or equal to 1200. So I have 7.1 plus 0.06747 times X, which this is my X, 960. So how much are we getting charged? We're talking about money. So we're going to round to the nearest cent. So I actually already have that in there. I'm just going to arrow up, change that to 960. Okay, talking about money, nearest cent. So 0.87, that one makes that 7 say. So $71.87 is my answer right there. So now what is the monthly charge if 1,580 kilowatts are being used? So this is my new X here. So now I'm using this bottom equation. We're going to use 88.06 plus our new rate. And then we have 1580 minus 1200. Now, really, I can put all of that in my calculator just the way it looks, but to kind of reiterate what I was explaining up here, this would be the same. 1580 minus 1200 is 380. And you can put that in our calculator. Okay, 380. So if I'm using this many kilowatts, I'm getting charged this amount right here for that first 1200. And now I'm going to get charged this new rate for the 380 kilowatts that I'm going over this 1200. Put this in our calculator. So we're again near a cent. So that 4 is going to make that 5 stay. So we would be charged $110.05 right there. Let me know if you have any questions about that. You will see this question or one extremely close to it in my math lab. So remember to convert your dollars to cents. Remember on that second one, it is X minus whatever that number there is.